So this video is on graphing an absolute value function. So the general equation for an absolute value is y is equal to a is a stretch, times the quantity x minus, times the absolute value x minus h plus k, where whatever makes this absolute value is going to be the x coordinate of your vertex. And then whatever's being added or subtracted outside is going to be your k, which is your y coordinate of your vertex. Now, for an absolute value, this A is like all the other graphs we've done, it is a stretch. But an absolute value graph is a V shape. So it is linear in nature. So this A, which is a stretch, you are timesing all of your outputs by whatever your A is. But it's also, since it's linear, like a slope. So first, let me just graph what an absolute value, basic y equal absolute value of x looks like. So just a little reminder that when you are taking the absolute value of something, it is how far I'm just going to use this x-axis kind of as a number line. So for example, this value over here, 5, let me make it a little bigger. This value 5 over here is 5 away from 0. So the absolute value of 5 is 5 because it's 5 away from 0. Absolute value is how far you are from 0. But if I'm over here at -5, -5 is also 5 away from 0. So the absolute value of 5 is equal to 5. And the absolute value of a -5 is equal to 5. So when you take the absolute value of a positive number or a negative number, you're always going to end up with a positive result. Okay, so let's graph an absolute value. So let me just get rid of these real quick. So when I'm doing our basic y equal the absolute value of x, I am going to take the absolute value of 0, and the absolute value of 0 is 0, so I have a point at 0, 0. When I go to 1, the absolute value of 1 is 1, so I have a point at 1, 1. The absolute value of 2 is 2, so I have a point at 2, 2. The absolute value of 3 is 3, so I have a point at 3, 3, and so forth. Now, when I go over to a -1, the absolute value of -1 is also 1, so I have a point at -1, 1. When I go over to -2, the absolute value of -2 is 2, so I have a point at -2, 2. And when I go over to -3, the absolute value of -3 is 3, so I have a point at -3, 3, and so forth. Now, what you'll notice is happening is I'm going up 1, out 1, up 1, out 1, up 1, out 1. And that's the same in this direction, okay? And then we would connect these points with a line, and it's going to form a V. So we're going to end up with a graph like this. Now, I'm going to show you on Desmos. I'm going to bring Desmos over here. So on Desmos, I have put in y equal the absolute value of x. And here you see all the points that I plotted. You see that I'm going up 1 over 1, up 1 over 1, up 1 over 1. Okay, because my A is a stretch of 1. Okay, that's my normal absolute value graph. Now, I am going to do, let's say, 1/2 to the y is equal to 1/2 times the absolute value of x. So that's what that graph looks like. Let me plot these points here. Now, what's happening is when I take the absolute value of 0, the absolute value of 0, 0, times it by 1/2, well, 0 times anything is 0. So this point does not change. When I go out to 1, the absolute value of 1 is 1, but instead of going up to 1, I'm going half as high. So I'm going up to 1/2. When I go out to 2, the absolute value of 2 is 2. So I should have gone up to 2. But again, I'm going to go half as high, and half of 2 is 1. One more. When I go out to 3, the absolute value of 3 is 3. but I'm going to go half of 3, which is 1.5. So when you're looking at this, I can sit here and take half of each of these values, but what you'll notice is, again, since this is linear, my stretch of 1/2 is really going to be like my slope. So I'm going to be going up 1, out 2, up 1, out 2, up 1, out 2, in both directions, up 1, out 2. Now, one more just to show us. So let's say it's a 2/3. Again, I'd be going 2/3 as high. So my 0 would not change, but when I went to 1, absolute value of 1 is 1, times it by 2/3 is 2/3. You see that it as a decimal here, okay? When I go out 2, the absolute value of 2 is 2, but when I times that by 2/3, I get 4/3, which is 1.3 repeating. And when I go out to 3, the absolute value of 3 is 3. When I times that by 2/3, I'm going to get a 2. So I can do all that math, but what happens is, again, since this is linear in nature, the stretch can be considered for only linear situations, lines and absolute values, as a slope. So if I come here to my vertex, I'm going up 2, out 1, 2, 3, up 2, out 1, 2, 3. And that's kind of an easier way of thinking about how to do these graphs. So let us try this one here. Okay, so let me hold on, get rid of this here. Okay, so let us try y is equal to the absolute value of x plus 4 plus 3. So when I'm doing this, first off, my vertex is going to be what makes this 0, which is going to be a -4, comma, this number, which is 3. That's going to be my vertex. So I am going to be going to -4, 3. That's where I'm going to start. And then since my A is 1, I'm really just going to be going up 1, out 1, up 1, out 1, up 1, out 1. And when I say up 1, out 1, I'm doing the same in both directions. Up 1, left 1, up 1, left 1, and so forth. And I'm going to get a V-shaped graph. And of course, we connect it. And I get my, let me try it one more time. And I get my V. Now, I'm going to go through another one. So when I go through this next one, here I have a stretch of 3/5, but I can also think of it for absolute value only or lines as a slope, not for any other ones of the graphs that we're dealing with, not for parabolas, not for cubic graphs, only for these linear looking graphs. So let me find first my vertex. And my vertex is going to be what makes this 0, which is -2, comma, this number, which is -3. So that's going to be my vertex. I'm going to go to -2 because of this, -3. So -2, let me scooch it down a little bit. Okay. Okay. So -2, -3. Sorry. Okay. So -2, -3 is going to be right down here. And then my stretch is 3/5. But again, for these V shape, these absolute value graphs, which are linear in nature, I'm going to think of it as a slope. I'm going to go up 1, 2, 3, out 1, 2, 3, 4, 5. So up 3, out 1, 2, 3, 4, 5. And then I would continue to do that, but I'm going to run out of room on this side. So let me just connect my points. Try that again. And same on the other side. And there is my absolute value graph. Try that one more time. There we go. Now, if I was to double check this, you'll see that if I was to substitute in, let's say this value here, 3, I should be getting a 0. This is 3 comma 0. So if I put 3 into this equation, I should be getting a 0. So let's see. Y is equal to 3/5 times the absolute value of 3 plus 2 minus 3. So inside my absolute value, my 3 plus 2 is going to be a 5. And when I take the absolute value of 5, I'm going to get a 5. So I'm going to have y is equal to 3/5 times 5 minus 3. And y is equal to 3/5. Let's make that look a little neater. 3/5 times 5 is a 15/5 or 3. So I'm going to get 3 minus 3, which is a 0. And so you do see that I ended up with 3 comma 0 without having to do all of that work. Okay, and let's try one more. This one has a negative. So for this one, again, I'm going to find my vertex. My vertex is going to be at 3 comma 8. So I am going to go to 3 comma 8. Okay, so 3 comma 8. And then from here, my slope or my stretch, but I'm going to think of it as a slope for absolute value, is a -2. So I'm going to go down to out 1, down to out 1, down to out 1, down to out 1, and so forth. So let me do the same on the other side. Down to out 1, down to out 1, down to out 1, down to out 1. And then we have our upside down, okay, open down, because of the negative outside of the absolute value graph. So hopefully that helps you graph an absolute value graph just by understanding how to graph the parent equation, then being able to find your vertex using what makes the absolute value 0, and then this number will become your y-coordinate. And your stretch for an absolute value graph is really a slope.